I could try to figure out what to do if you need some help. I'm sitting here.
Okay, yes, so for the moment we are controlling the slides. Okay, so if, yeah. Okay, so if you agree, let's maybe start. Okay. Hello. So welcome to the meeting of the 6LOW Working Group. If we can see the previous slide. Okay, thank you. So my name is Carlos Gomez. The other chair is Shweta Bandari. Our responsible AD is Eric Klein, who is also today sitting at the table. Thank you, Eric. And we have minute takers. Dominique has volunteered. So thank you very much, Dominique, once again for helping taking minutes. Is there perhaps anyone else who would like to volunteer to take minutes?
Here.
So, okay, someone said something in the room. Do we have a volunteer? Okay. Anyway, recall that we are taking minutes by using HedgeDoc. So this is a collaborative process and everyone is welcome to join and contribute to the process of taking minutes. And thank you in advance. And also we might need a Java or perhaps today a Zulip scribe as well. So if anyone would like to volunteer, please let us know. Okay. And also on the agenda, you can find a couple of pointers. One is the link to the online agenda, and the other one is the link to the HedgeDoc that we are using today for taking minutes. So next, please. So this is the second IETF meeting that has an in-person component since the start of the COVID pandemic. So there are a few meeting tips to keep in mind. So basically they are the same as for the last IETF. For in-person participants, please make sure to sign into the session by using Meetecho. For example, you may use the on-site tool, which is available from the data tracker agenda. And the very important point is that actually we're going to use Meetecho to manage the queue. So if you want to join the queue, please do that through Meetecho, as there is a single unified queue handled in this way. And also blue sheets are automatically generated from Meetecho. So please, if you are in the room, please make sure that you join Meetecho. And for remote participants, just keep in mind that you need to keep your audio and video off unless you are presenting. Next, please. So this is the note well. This is a reminder of IETF policies on various important topics, such as patents, code of conduct, and so on. So if you are not familiar with it, please make sure that you have read it. Next, please. And this is the agenda proposed for today. So the first presentation is the usual chair's introduction that's currently in progress. This will be followed by a presentation on the status update of the 6LOW use cases draft by Jon. That will be followed by the presentation on the MD multicast address listener registration draft by Pascal, and a discussion on the next steps for the draft. Then the next will be a presentation on the transmission of SHIP compressed packets over 50.4 networks. And this will be followed by a set of two presentations that focus on the native short address scheme. The first one is the presentation on the base document, and the second one is a companion document focusing on reliability considerations that is presented for the first time. Both will be given by Luigi Andone. So as you can see, the total scheduled time is 60 minutes, so we have a packed agenda. Also, we would like to kindly request the presenters to try to stick to the allocated time. And well, is there any comment, any question on the agenda? Okay, so if there are no comments, then, yeah, let's proceed to the report of the working group document status. So the first document that we have on the table is, again, the IPv6 over NFC draft, which, as you may recall, was evaluated by the ISG, then it was updated after that, and now it has been stuck for 2 years now. So perhaps, Eric, if you can let us know about details about the next steps, any plans for that?
Yeah, this is my fault. I have not been able to prioritize this, but I know that I need to. I had some discussion with Lars, I think, and some others, and I think we can demonstrate that everybody who had access to the who needed to have access to the spec had access to it, and also that those that did not, it's not terribly different from other wireless standards, and certainly not from an IPv6 interface definition. So I think there's some clarifying text to the security considerations we might make, and probably the right thing to do is to maybe bring it back to the IESG.
Thank you. So one clarifying question regarding the point of anyone who might like to have access to the specification. Does it mean that if any folks approach the authors, who I understand at least then they have a copy of the specification, is that enough, or should there be some sort of announcement or wider broadcast of how to access the specification?
I think the former is probably enough. I think.
Okay.
I don't think it's terribly contentious enough, or it's terribly. There's enough interest to warrant worrying about spreading the information, and I also don't want to violate any sort of the NFC SDO, their standard distribution orders,
yeah,
or recommendations. So
okay.
For those for whom they feel it's necessary for review, they should be able to review the essential components. I feel that's fair.
Okay, thank you. So the next document is IPv6 over PLC. You may recall that all the discussed ballots have been cleared. The authors updated the draft after that, incorporating the last remaining set of comments as well. So, however, if I understand it correctly, Eric, there has been some changes in ISG membership, so new ISG members need to provide also some ballots, right?
That's correct. We lost some ballot positions during the changeover, and I failed to advance it prior to that. And so I've sent email to their remaining and to the new and to those with no record ballot to ask if we could get 2 more reviews. I think we only need 2 more at this point, and then or 2 more no objection or yes ballots. If there are discussed points, we'll have to take care of that. But I think we've already dealt with difficult discussed issues, so I'm not anticipating any particular difficulty. If we get 2 more, so I'm beating the bushes trying to get 2 more reviews, and after that we can send it off to the RFC editor.
Great, thank you. Then the next one is 6LoW use cases draft. It has been evaluated by the Security Area Directorate and the General Area, and it has been updated as a result, and there will be a presentation later today on this draft. And well, perhaps, I don't know if the next step may be that after that it will be ready for telechat. Anyway, yeah, Eric?
Yes, I think it passed last call. I just need to issue the ballot and bring it to telechat, which I should be able to do by the end of August.
Great, thank you. And finally, the multicast address listener registration document has been updated several times since the last IETF. Thanks to Michael Richardson and Rahul Yadhav for reviewing the draft. Thanks a lot. And also there has been an update after an IANA review. So this will be presented and discussed later today. So any other point, any comment? Okay, so if there are no questions, then we can proceed to the next presentation on the use cases draft.
Okay, nice to meet you. My name is Yonggun Hong. I'll present the 6-row applicability and the use case document. Could you, next page, please.
Yeah.
Oh, okay, thank you. Yes, this is history and status. 2018, the first working group last call, and the second working group last call was 2020 October. And this year, February, it is submitted to ISG, and this is the 13th revision. Next page, please. Yeah. So after last meeting, we got few comment from security director Robert Spark, and the other is to Peter Wee, General Art. I sincerely thanks to Robert Spark and Peter Wee. The comment from the Robert Spark, he says he has some issue, so I'll talk about in more detail. And the comment from Peter Wee, he said they're ready with the issue, so his comment was mainly for the minor issue. Okay, next page, please. Okay, I talk about the comment from Robert Spark. The first one is the security consideration. Originally, this document is the use case document. So if you see the section 7, security consideration, there is two sentences. Security consideration are not directly applicable to the document for the use cases. The security requirement describes in the protocol question apply. But he says that the text of this draft has several phrases that rightly call out their implication of privacy. Privacy also become a serious issue, and the assumption is that L2 security must be present. So he recommends to add more sentence for the security consideration. So if you see the blue box, I add the newly added. That is, the 6-row stack used the IPv6 address model, and it is required to consider the implication for privacy with L2 address derived IPv6 addresses. In a typical 6-row use cases with a variety of secure data, it is also required to provide secure data transmission. Even though the 6-row stack do not address security at the network layer, it is required to provide L2 level security, and the application level security is highly desirable. But after submission of this revision of document, I got a response from Robert Spark, but he does not satisfy, so I need to enhance more in the next revision. Okay, next page, please. Yeah, and another is also related to security. So if you table 2, there are some the law for which is regarding to security requirement for each G-Wave, BLE, DEC, MSTP, and NFC and PLC. But he suggests that the content is not clear. So I think that it is better to remove the role itself. So in the updated revision, I deleted this part. Next page, please. Yeah, the third comment from Robert Spark is that Appendix A, in previous revision, there is Appendix A. It is the design space dimension for 6-row deployment. Could you next page, please? Yeah. In Appendix A, design space dimension for 6-row deployment, there are some description of deployment, photo swapping, topology, L2 mesh or L3 mesh, multi-link subnet data radar, blah, blah, blah. So this is not directly related to 6-row or 6-row band technology, but it is helpful to understand and helpful to design for the network. So yes, could you back to one page, please? Oh, sorry.
Back one.
Yeah, back. Yeah. So he says that Appendix A is neither introduced nor referenced from the body of the document. Yes, it is true. So, you know, in IETF 106 meeting, there are comments that this document is a little too long, so it must be short and it narrow down and focus something. So reflect the comment, this section was originally section 5.1, but it was moved to Appendix A. But now the relationship from the main body is not exist. So I would like to ask how to handle the Appendix A. My personal opinion is to remove this Appendix A if it is not important. Okay, next page, please. Okay, next page. Yeah, the final comment from Robert Spark is that this document has some the misuse of dictionary description and marketing words. For example, superior, range. So he suggests to change to better than or goes further. So I agree that because this draft has some parts which are recognized as marketing word because we invited some expert. For example, thread or electricity or Wyson, etc. So there are some the use of the marketing words. So I try to change the marketing words to technology words in this revision. Okay, next page, please. Yeah, this is a comment from Peter Lee. He says that there are no major issue and there are some minor issues. 2 or 30 items. So I try to update to reflect all minor issue in this revision. Okay, next page, please. Yeah, that's all. Yeah, thank you.
Okay, so one comment, by the way, as co-author of the document, regarding Appendix A, there is a paragraph at the end of the introduction which says that the document covers design dimensions and so on. So removing the appendix may be one approach, but another approach is to add a forward reference from the last paragraph to this Appendix A. And also, if I'm not mistaken, I think that there's a comparison table where each row in the table is based on the different design space dimensions. So we can discuss maybe offline or later how to proceed, but another approach is keeping the appendix and maybe adding some forward reference, but we can discuss.
Okay, thank you.
Yes,
Hi,
Luigi.
Luigi. Yeah. I do agree with Carlos. I do apologize. I didn't read the appendix, but I don't think that just removing it without just for an editorial issue makes sense. The first question is there any information that is useful? If yes, then the solution of Carlos is the best way forward, in my opinion.
Okay, thank you.
I'll insert myself in the queue here and say on the security considerations stuff, there's plenty of text that we can point to from RFC 8200 security section, and 8200 has links to other security documents for IPv6 neighbor discovery security considerations. So I don't know if that would satisfy Robert's concern, but we could certainly point to all the other security sections and all the other things. It's basically because there's nothing. There are no new security considerations per se, right? I mean, all the security considerations are things that affect all the sub IP layers for all of IPv6. Yeah, so we can just point to a bunch of existing text, I think. I'll send some mail about that.
Okay, so if there are no other comments on the draft, next we proceed to the multicast address listener registration presentation by Pascal.
Hello, Carlos, can you hear me okay?
Yes, perfect.
So sorry not to be here with you guys. So yes, we are now deep into the process of the multicast registration document. So this document was stimulated by work which happened effectively in an alliance, an industry alliance called YSAN that was just mentioned, where they use 6LoW and RAW RFCs to build a solution for mostly for the smart grid over IETF 2.15.4. So the multicast registration came from the realization that they still had to do a lot of link layer multicast to support MLD, even if we managed to avoid it for ND. So that was their question. I mean, how could we do the equivalent of MLD, but in a way that is a pull from the device as opposed to from the router, basically or a push, call it a push from the device as opposed to a pull from the router. So the device would not have to be listening to periodic MLD reports. So next slide, please. So we started with this, and we ended up also looking at the way the multicast is distributed in REPL. And since, as you know, most of the IoT cases of REPL are using non-storing mode, we figured that there was a need as well to enable the multicast across the non-storing mode network. And so we did that as well. So the draft actually ends up doing work for 6LoW, but also work for RAW. So in this new update, and since basically there were 2 or 3 updates since IETF 1.13, it was mostly clarification. It's not like, well, there is one thing I will show you on the next slide, but most of the rest is clarification. So we clarified that effectively it's a push from the device when the device wakes, as opposed to a pull from MLD, which would require the device to stay awake. A clarification that the TID, the sequence number that is in the error option and in REPL as well, is not used for freshness assertion, since Anycast and multicast come from different sources that are not necessarily synchronized for setting the TID. So we clarified that the TID is not checked, and so the state actually disappears with a lifetime timeout. So that's why it's important that the lifetime is chosen correctly. And the big change is basically a comment, I think it was from you, Carlos, and I'm not too sure anymore. But basically, the question was, how, if the router reboots, how do we know that it needs to fetch some state? And so we did 2 things. The first thing, which really addresses the low power devices, is a multicast arrow status that can be sent asynchronously in an NA message, Anycast or multicast, which will basically say, hey, any state I would have had, I can have lost. And so please refresh. And since this is a pull by the router, again, it's something that the low power devices might miss. It actually shoots the lower layer that YSAN, for instance, has, because they effectively have a multicast periodic window, so they can use that. But for other IoT devices or IoT networks where there is not such a periodic multicast window, then it might be that this NA is missed by the devices. So we also introduced something for the array, which is the node uptime option. It's going to be next slide. And finally, I had some early comments by Amanda Baber about the IANA section. So I cleaned the wording of the IANA section to make it fit the way IANA wants it written. So that's already done. That will save us time on the publication process. Now, what is this new node uptime option? It is something that was needed in RFC 8505 that was not there because at the time we didn't really care about going to a network where there would not be enough reliability on the routers, basically. And so now we figure that it was actually a miss. It was a command that we got a number of times. And so we kind of leverage this specification and the particular discussion we had on the NA with this new status to effectively add the option in arrays. So it is something that will require 6-man visibility. So now I'm talking to Eric, since Eric, I see you here. We are proposing a new option in the array to basically tell, well, for the array to say how long this router has been up. It's basically the sequence and a time. And so the time is split in two fields. One is an exponent, and then there is a mantisar. This allows to express very short and very long times, depending on what the exponent is, with 2 bytes. So we kept it short because, you know, there are many things in arrays. And so that's why we compressed the value. This basically says in an agnostic fashion, you know, this router has been up for this time. And so if you registered, if the node uses that to register, and you registered longer, before basically the beginning of the new life of this router, then the device can figure that the router is not aware of the registration status of this device, and this device should re-register. So this is basically another way for advertising that the device is has reboot. So the router has reboot. Then again, the array itself can be a multicast, and then again, the device might not be listening to it. But it can also be stimulated by the device sending an RS. If it fails to connect or something, or it just sends an RS to the old router, so it's still available. And with this RS, the router will reply with another type option, and the host will basically see that the router has not been up for so long. So this is the second way, basically, that we propose to enable the host to discover that the router has been down and has lost registration state. Next slide, please. So that's basically it. I mean, effectively, the document has been stable apart from this addition, this last time addition about, you know, awareness of the router status and how long the router has been available. So I understand that, you know, that this is a cross-area discussion. We have some work which interests roles, which interests role, some work which interests 6LoW. We decided to package that together to have a consistent story, so people would see exactly what's going on for multicast. And with this, I will leave, you know, for questions, and then if the chairs want to say something about next steps. Carles?
So if there are no questions, basically we discussed with the role chairs and we informed our respective ADs about the plan. So the plan would be that if there is no significant issue raised in this meeting, then we plan to launch a coordinated working group last call, which will happen in both 6LoW and role working groups. And, well, on the other hand, 6LoW will remain as the home working group regarding shepherding, making decisions, and so on. But anyway, the process will be coordinated with role.
And then there is this new option, right? The uptime, for which we need to coordinate with 6-man. I mean, either 6-man opposes, in which case we can retract it from the document, or it flies with 6-man, in which case we can leave it. So basically, there's always this risk.
Do you plan to present the draft in 6-man this week?
I would like to present the option at 6-man at the next. But if it could be discussed on Timothy, yeah, Tim, since you reviewed the other documents for 6-man.
Yeah, I think you could. Tim Winters, QA Cafe. I think you could send it to 6-man, but I also was wondering about a multicast group. Should maybe look at this one because it's got a lot of multicast I don't think the whole working group needs to look at it, but I think you probably want to check in. I'm guessing PIN is the last, or M-bone would be. Either one of those would be popped into my brain. It's just having them look at this and from a multicast perspective. But yeah, 6-man, I don't think it's on the agenda, but I think you should run it by the working group for sure because of the options.
Yeah, that's interesting. We are effectively, Tim, we actually got that remark long ago, I mean, at the beginning of this document about multicast. And as it goes, what you need to see is there is multicast in the original repo using the preferred parent tree inside the repo, but that's for storing mode. And here, this is kind of specific. We are doing non-storing. So what happens is the root of the repo graph will basically do ingress replication and tunnel. So there is, even though it's a multicast registration, there is no real multicast operation inside the graph. It's just ingress replication over tunnels to the edge routers. So yeah, it's a flat unusual for multicast.
Okay.
So Eric, what would be your suggestion for the array option? How should we move forward with this one? Eric?
I admit that I don't fully understand what its intended use case is. Anything that goes into the RA, in normal ND semantics means it's only all the information in the RA must be consumable by all multicast by all nodes recipients, right?
Yeah, and this is why it's very abstract. Can you go back one slide or two, please? Yeah, this one. So back. Yeah, this one. So here is the option. The only thing it says really is how long this router has been up. Because when the router goes away, it can send a final array, and some people might miss it, and the router reboots, and if they have done whatever, and it's completely agnostic to what they have done with this router, maybe they will be interested in knowing that the router has rebooted and has been alive for this long. That's the only thing that the option says. It basically says the router has been up for this long. And so in our case, we use it to presume that the router has lost state. And that's valid for any kind of state that the host and the router could form.
Does this, could this, that sounds like the thing that could have some applicability to multiple considerations. Can it be a document on its own, just about this option?
Yeah, I could do that too, I guess, if that's what the group prefers. Now, the only thing is, will this document be blocked, or is there a way? Yeah, I guess we can write it such a way that it augments this one without amending it, right? So if we take it separately, I'm willing to do that, yes. Then I would just take off the reference to that document, publish again, to that option, publish again, without it, and then make it a separate draft, and the separate draft would say, oh, it can be used, for instance, for this draft. Is that the way you would?
Yeah, I could see where this could be useful for detecting reboots and possibly for some of the Slack renumbering concerns. There were similar, I think nothing written, but there were similar discussions about having some kind of a generation number or generation ID.
Which is the NSSI probably, yeah.
But I can't recall if there was any draft actually written about that. But
okay, so your suggestion is take it on a separate draft, right? Make it a very short, simple draft for 6-man.
Yeah, and the thing is, you're going to have to decide how much you want to tempt fate in that draft by listing various conceivable use cases, given that they might all be picked apart by people to say whether it is or is not useful. It might be better to just assert that it is, or it could be useful.
So I can basically take this document, we can progress this document and use it as one reference that this thing is useful?
Because you're going to, yes, I think you're also going to need, yeah, it's going to have an accompanying operational guidance section, right? That routers must reset.
I guess there is, but I can take all that text off this document. I mean, it's more of a, you know, almost last minute addition. And, you know, the requirement that we make this RFC with a certain set of requirements in mind. And for the set of requirements that we have in mind, there is effectively a multicast channels. I mean, most of the IoT networks I'm aware of, they have a multicast channel. They don't want, it's not fat, right? You can't use it often, but it exists. And so we can use the NA with the new status. And that's enough, for instance, for YSUN. So it's okay for me to remove that option and put it in a separate document. We still have a consistent solution, but we only have the NA, we don't have the array. The array was, you know, for the use case I'm aware of, it was nice to have.
Yeah, I don't know. I haven't. I don't know how the document stands with this piece removed. So I wouldn't.
Well, it was like that all the time. It's a very recent addition. So I guess it would stand. I mean, we want this option. It's more like this was a way to avoid doing yet another RFC. But if your recommendation is effectively to do yet another RFC, then just to keep things separate, then we'll do it. We kind of package the full solution in one RFC in this case. We have 6LoW, we have RAW. And so we would have had a little bit of 6-man as well. But if that's not the proper way for 6-man, then we can take that off, make it separate.
Yeah, I mean, you can. I don't know, maybe we should talk to the 6-man chairs, see what they think about a separate document, how that might be received. Whether that's useful, if you're up for it.
I mean, I'm open. I mean, the document can live without it. I needed a vector to carry it, so that was one way. If you tell me there's a better way, I'll take the better way.
I don't know exactly what a better way might be just yet, but yeah, we can talk about it offline.
Yeah, with Eric and the 6-man chairs. I'm pretty open. So yeah, and I will update the document based on that conclusion, and then we can launch the workgroup last call on both sides. I guess we can do the workgroup last calls with the current document, but if the chairs prefer, I can take it off. Just let me know.
Yeah, maybe once Eric has a response from the 6-man chairs, yeah, probably it may be cleaner to launch the working call with a separate part. I don't know if the whole
with whatever they conclude, right? So if they decide that I should remove that section, make it separate, then I'll do it, and then we can launch workgroup last call. If they say it's okay, let's just circulate it by 6-man, then we'll do that as well. So basically, we will be holding. That's how I understand, right? We'll be holding the workgroup last call till Eric gives us the green light and the action to be taken.
If I understood that correctly, you're going to wait for me to send email and CC you and the chairs to talk about.
Yeah, basically, we will be waiting for a recommendation by you, Eric, Vink, 6-man ADs, 6-man chairs, I'm sorry, about making it separate or circulating it through 6-man SCS.
Yep, I can start that email thread, and then we can see where it goes.
Nice. That's it on my side. That's where we are. Thank you very much, guys.
Okay, thank you, Pascal. So I guess, yeah. Okay, I'll try to make it fast. So I'm going to present the update of the draft entitled Transmission of Sheet Compressed Package over 15.4 networks. My co-author is Ana Miraburo from Aclio. Next, please. So basically, here there are some numbers. This is about the motivation for the draft. The idea is that with SHIC, in some cases, we are able to achieve greater header compression ratio than with traditional 6-low-pan header compression, especially if we consider also compression of application layer protocols like CoAP. So the expectation is this should lead to some significant performance improvement. Next, please. Sorry. Oh, we've lost the slides. I think Shweta is offline at the moment. So I don't know if Eric, is it possible?
Yes, I could try. I don't know how to share from here. I tried to make myself, yes, a delegate. So, but this will be the first time I've ever tried to do that. Let's see here. Nope, that just opens this.
Okay, maybe.
I can open the materials. I don't know how to share them.
Okay, maybe.
Here we go.
Okay.
This one. Share.
Yeah, so I'm seeing them on the screen now. So if you can go to slide number 3, please.
Is that Shweta back? No.
No, I guess it's you who is now. Can you control the slides?
Yes.
Yeah.
It's just, take me away to several.
Okay, thank you. So basically, I'm presenting revision 03 of the document, which tries to enable the transmission of SHIC compressed packets over 15.4 networks. Next, please. So yeah, on the updates in the draft, you may recall that there was a problem with how we are going to compress IPv6 addresses and UDP ports by using SHIC. So SHIC uses deb and app terms in its specification that corresponds to a constrained device. On the left in the figure, app corresponds to a network site infrastructure, not constrained on the right. And the SHIC specification, this RFC 8724, defines that compression of IPv6 addresses and UDP ports is performed expressing who is deb and who is app, and not in terms of what is the source or the destination of these fields. So here the point is that because an entity knows in advance whether it corresponds to deb and app, in SHIC, then this allows some optimization because a single compression rule allows it to be usable in both directions as expressed in terms of deb and app. However, well, the point is that in some 15.4 scenarios, we can still use this optimization as is, for example, in star topology networks. However, if you go to slide number 5, next slide, please. There are some other scenarios in 15.4 where we cannot just use the same approach as is, because, for example, two peers within a mesh topology might be candidates to be considered deb. So then who is deb, who is app? So this is the problem. The consensus so far has been trying to stick to the deb and app terms because they are very much at the core of SHIC and they still allow this optimization of using a single rule for compression in both directions. And in version 03, we now state that the SHIC compression, decompression entity needs to know which is the role developed for each one of the rules that are going to be used in communication. And actually this needs to be known in advance before communication happens. And well, knowing the role in advance makes sense because the rules also need to be written beforehand in advance before communication happens. Also now in 03, we reference the LP1 architecture draft. So this has some additions. It will be discussed, by the way, the architecture draft in the LP1 working group later this week. And the idea is that it starts to provide a solution on this problem of who is that, who is that in environments which are outside or beyond the original LP1 architecture. Next, please. So we've added a new section entitled Multi-Hop Communication, where we explain that we can use route over, which means that routing is performed at the IP layer. There is one straightforward approach that may be used to transmit sheet compressed packets, in this case, which, however, requires all nodes to store all the rules in using the network. So this presents some challenges in terms of scalability, in terms of network size, memory, and so on. So an alternative is that if Ripple is used as the routing protocol, then as suggested by Pascal, we can exploit Ripple non-storing mode and use RFC 8138 to make it efficient. And in this case, an endpoint must only store the rules for the communications it is involved in. So this is some idea that we plan to develop and elaborate in subsequent versions of the draft. And then we can also use mesh under. In this case, there is no particular challenge to enable the transmission of sheet compressed packets here. Again, in this case, an endpoint just will not need to store the rules for the communications it is involved in. And as a sort of optimization for reducing further the header, we state that the rule ID may be reused across these joint pairs of endpoints. However, this means greater complexity. So this is just some idea at the moment. Pascal?
Yes, sorry for the gory details, but in non-storing, we can use non-storing mode in Ripple, even if the main DODAG is storing mode. And we do that for low power devices which are not Ripple aware. And we can expect that a device that needs SHIC is probably not Ripple aware, and it's probably one of those low power devices. So it makes a lot of sense to not contribute, to not participate to Ripple, use the Ripple unaware leaf mode, in which case it's always Ripple non-storing. So when it's Ripple non-storing, there is a tunnel between the first router and the root. So basically, the root would have to know the rules for everybody, and the leaf would just need their own set of rules. So it's not with every communication. I mean, the wording is not entirely crisp. It's not the communication between two endpoints. It's every endpoint communicating to the root. The root will decapsulate, will decompress, may recompress if the destination is inside the DAG, or it will just send to whatever up there. But basically, the compression would happen over the Ripple network, over the device to root tunnel. And yeah, we need basically the 6LR. We would need to spend some time explaining exactly how it works, but that's what would happen. Basically, the session would be oriented, the hub would be the root. So there is enough discussion on the LP1 specification that when there is a hub and spokes, the hub is effectively the node that has rule for every spoke, and it is up, basically. It is the upside. So yes, it kind of flies.
Yes, I have maybe some comment as Pascal. If you use Ripple, then you have a up and a down, so it's very, very close.
We use it, Laurent. We use it. It is the up and the down. It's completely consistent with the architecture. It's just that the question was who has to have the rules, and the root must have the rules to every Ripple unaware leaf, right? Because there will be a tunnel between the Ripple unaware leaf and the root. But the Ripple unaware leaf just needs its own set of rules, and it doesn't need the set of rules of anybody else, because the root will decompress and recompress if needed. It's just the interaction between the Ripple unaware leaf and the first 6LR, if we want to already send SHIC compressed packets there. So, or if we want the first 6LR to do the compression on behalf of the Ripple unaware leaf, which is another possibility.
Okay, thank you. So I guess we'll elaborate on the details. And if we go quickly, because we're running out of time, to the next slide. So yeah, basically we are recommending that in the case of route over, virtual reassembly buffer should be used. So I guess we should stop here due to the lack of time, and we can continue discussing on the list. And I guess that we can proceed with the next presentations on NSA by Luigi.
Hello. So in principle, I can control the slides from my mobile phone. I send a request. The chairs, I guess, should allow me to do it. Wonderful. Here's the one. Okay, so I have shrinked my presentation from 20 minutes to 10, less than 10. The first presentation is a very quick update on the NSA, the native short addressing. So we did an update in June fixing the last concerns that were raised, okay? We did again, as usual, the typos hunting. With the one main change is about reliability. I will come back to this in a couple of slides. We added clarification about the checksum calculation for the transport layer. That was important, and minor changes. We need one new pending because we had an exchange with Carlos, which yes, makes sense to update a reference and clarify another point. One thing that we did, Pascal actually raised the issue about reliability, very important thing. And we actually discussed for a while how to approach this part. And what we decided is actually to have a separate document, because this reliability can be guaranteed in different ways. There is no one that is, at the end, really specific about the NSA. So we took out an old section that was called benefits of native short addressing, which anyway was partially talking about the reliability. And we added a small reliability consideration section where what we do basically, we discuss our routing versus stateless forwarding, because at the end of the day, what we do with NSA is stateless forwarding. We structure the addressing space in such a way that we have an idea where to send the packet. A few words about the fact that the reliability is a multifaceted problem, and obviously we reference the new document. So this is what the status on 113. So we had few things to update, okay, to incorporate. This has been done. We said we're gonna issue revision 3 after 113. We did, okay. Again, we have these small things to be added, but it's very minor. So we think really that the document is pretty stable, and unless there are main concerns that someone has, we think we can go forward for working group adoption. I mean, we were kind of hinting on this on the 113, but we had some work to do. Now it's done, and we consider that is relatively stable, the document. And that's it for this one. 3 minutes. So unless there are questions, I guess this goes to the chairs about how do they want to proceed about the working group adoption call.
Yes, so perhaps it may be good to have at least a first sense of the room on adoption. So I will use the show of hands tool. So I am using the show of hands tool. Please raise your hand if you have read any version of the draft. Okay, so at the moment, at least 9 people have read at least a version of the draft. 10. So this is to get some sense of the room. We are not making a decision at the moment. Okay. And yeah, so then the idea will be to move to the mailing list. We're going to discuss and yeah, issuing a working group, a call for working group adoption will happen on the mailing list. So next,
Okay.
if you want to use the last remaining minutes for the presentation on reliability.
I can go very quickly on just to show the main approaches that we have there. Yeah.
Sure. Also, usually the room is closed 5 minutes past the official time, so maybe let's use some additional extra time out from there.
I will try to stay in the 4 minutes remaining. It's a challenge.
Okay. Thank you.
But I still see this, who has read any version of the draft on the screen. I think it's up to you, Carlos, to take it out somehow.
Yes, now it should be out.
Huh? Yeah, I have permission already. This is the right set of slides. No, this is the chest. I see. Okay. Okay, sorry, I misunderstood. Okay. So this is now new draft that we build in order to tackle this issue about reliability. This is very important. So the main point is that there are several classes of solution that we can use. The most important one, let me go, is the fact that obviously we need some prerequisites. So the fact that actually we have redundant links. Now the question then is, you can build multiple topology using multiple addresses, or you just decide which link do you use. You use one single address for each node, and you try to remember which link is active, which one is not used. Okay, so basically in the multiple addresses solution, what you do is you build several topologies, which means basically, if you remember, NSA is based on a tree topology. So you have a second root, and you add a secondary address for the nodes. So by doing so, you have two completely orthogonal topologies, and you use it as a primary topology, and then you have to decide when to switch to the second one when there is a failure. Now here there is such an example where the red cross obviously is a failure. What happens is a node can send through the secondary topology an ICMP message to the main root to say, look, this branch of the tree, the subtree, is not reachable anymore because I see a failure. Okay, and in this way the root can store this information and redirect the traffic when needed. Same thing when we have a link that is broken, you have to do the same thing from both sides so that you redirect in the right way. Okay, so that you still have the reachability all the time. Pascal, you have a question already?
Yes, if for instance you have the breakage that you show here, but it's 1000. The guy on the bottom left, it's not aware of that breakage, is it? Not 1000 yellow.
1000, yes, is not aware. What happens if he sends traffic upward is 100 that redirects the traffic. Doesn't need to be there is just one thing, but is meaningful. What you said is You can consider optional to send an ICMP downwards, and you say you may consider to use your secondary address in order to bypass all of this. Okay. Now,
yeah, but you have no choice because 100 will not get the traffic. I mean, one would have to figure out that along the path there is a breakage, and then it needs to take the bypass. I mean, it's kind of my bottom line is you're starting to do a routing protocol. As soon as you start doing this, you put your hands on, you open the Pandora box of a routing protocol.
Sorry, for me, your voice was not clear. Can you repeat the point?
Oh, I'm sorry. Let me say again. Doing all those things, you're opening the Pandora box of a routing protocol. So the whole deal was you don't need a routing protocol, and now you're starting to do one.
So this is things we discussed a little bit in the draft, but we need to clarify more. The point is, if you have few failures, you have a few very small state and few redirections, and everything works fine. But as long as you have something that's more unstable, more failures, more dynamicity, this goes back to routing, indeed. And in a certain way, so the other solution goes along what you are saying, because we use still redundant links, but we use just one single addressing space. So every node has one single address, but it has to store alternate neighbors, like an alternate parent, different childs, and so to make a decision when there is a failure. Let me go maybe to the final slide here. The point is, with what we discussed in this document, is if you use multiple addresses, in the root you have very low state, because it really depends how many failures do you have. Okay, and also the state that you put into the nodes is pretty low. But because everything is done locally in a certain way, and there is no coordination at all, the more failures you have, I mean, the more messy you end up, and there is less guarantee that there is a feasible path. Okay, with a single address solution, okay, the root in a certain way, it has to have a good knowledge of the topology, whole the topology, so the state is higher. Okay, on the single node, we still have low state because it's basically neighborhood. Okay, but the robustness is higher just because you concentrate the knowledge in the roots, so there is more coordination and more failures that you can keep up with. So, but you're right, there are trade-offs, and then at some point, if you consider that your network is not as stable and reliable as you think, certainly you have to think whether or not to put routing. Okay, Adnan?
Hello, Adnan. We cannot hear you.
Yes. Can you hear me now? Hello?
Yes.
Yes, Luigi, have you tested the failure scenarios of the with multiple addresses? I mean, if you are saying it's not reliable, so LLN is not reliable actually. Their nature is actually like this. So I think, can you tell me the failure scenarios you guys have tested?
Okay, sorry to interrupt. I guess in some seconds we are going to get the room closed. So perhaps we can continue discussing offline and maybe answer to the question on the mailing list.
Yeah, mailing list is better.
Yeah. Send an email on the mailing list. I will be happy to answer.
Sure.
Okay, so thank you everyone for the discussions and presentations. So let's hope that we can see each other in London. And yeah, perhaps we should also ask for a longer session. Okay, so have a nice IETF week. Thank you.
Thank you, everyone.
Hi, Dominic.